Good evening, students. My name is AZEEM. Today let us discuss about the topic that is solutions. Solutions. It is the lesson from the second year topic. It is second year topic. It is solutions. It is the second lesson. It is the second lesson. Let's put this one. Next, from this one, let us see about the molarity first. So before learning about this one, the solutions, the basics about the solution. What is a solution? What is a solute? And what is a solvent? So about this one, we should learn. Okay, so about this one, number of times we also learned about this one. It is very easy. Solution is nothing but a mixture of homogeneous components, or that is correct like this one. A homogeneous mixture of two or more compounds. Two or more compounds. Understood? So it is about the solution definition. Next, solute means, for example, if it is a binary solution. It is binary solution. For example, in the binary solution, only two components will be there. Only two components. So from them, one can be solute and another will be solvent. For example, in a glass of water, 1 liter of, for example, 1 liter of water I have taken. So in this 1 liter of glass, 1 tablespoon of sugar is added to this one. So what is less quantity here? The less quantity is sugar. Got it? And the more quantity is water. Water is more quantity. What is less in quantity? That is solute. What is more in quantity? That is solvent. Understood this one. So solvent means it will be more in quantity in the solution, in the mixture. Understood. Next, next what we can say about this one? In what we dissolve the solute, that is solvent. What is to be dissolved in the solvent, that is the solute. Okay. In one word, if we say lesser quantity is solute, more quantity is a solvent. So it is about the solute and the solvent. So from this one, the important one, that is about the molarity. Now we will discuss molarity. This one can explain about the concentration of the solution. Concentration, how it increases? By adding the solute. For example, a glass of water is there. In that one, some quantity of sugar is salt is added. So its concentration can be less. Another some quantity is added. Concentration increases. Another some quantity of salt. Concentration again increases. So the number of moles of salt increases, then the concentration of this also increases. The concentration of it can be denoted with the molarity. So now let us see about the molarity. So what is molarity? Already this one it is here. So about molarity let us learn. What is molarity? As a definition, if we say, it is just the solute, the number of solute molecules, number of moles of solute in one word is number of moles of solute present in 1 liter of solution. Understood? So this is the definition about the molarity equals. But in the commodity level, the definition only for the concept only we learn this one. The formula only used here. Molarity that can be denoted with capital M. It is equals to number of moles of solute. In the binary solution, I already told you that solute and solvent will be there. Solute and solvent. Solute will be less in quantity. Solvent will be large in quantity. Understood this one? The solute can be denoted with the second number. Solvent can be denoted with the first number. Understood this one? So this is the order. N2 we wrote here. N2 means here. N2 means it is the N2 means number of moles of solute. Okay, second one denote the solute. Next number of moles of solute by volume of solution. Volume of solution in liters. Understood this one? So this is the formula for the molarity. Okay, these formulas are very very important. Next, this one IHs we can't apply in the directly. Sometimes the value may be given, sometimes it may be given with different values also. Let us see another one. For example, here N2 and volume of solution is in liters it is there, but in liters we should not take it maximum. That we can take in milliliters itself. Understood? Milliliters itself. So in milliliters if it changes, so volume in milliliters when you write in milliliters if you write here into 1000 cups. Okay, so into 1000 volume. Okay, volume here into 1000 by volume in milliliters. Now the units is changed here. Now the units is changed here. Understood this one? Next, number of moles of solute. How can you find? Number of moles of a solute equals to number of moles of solute equals to number of moles of any component also. Any component number of moles also weight by molecular weight. Weight by molecular weight. Only by the formula weight by molecular weight only we can find the number of moles of the component. It may be solvent to solute to anything also. Understood? So here N2 it is the number of moles of solute. That's why here weight of solute is taken. Weight of solute by molecular weight. Gram molar weight also molecular weight of solute. Molecular weight of solute. So weight of solute already I told you. With the two number we can denote this one. That's why this one can write N2 equals to W2 by M2. Okay, weight or mass. Mass or weight, both of them also same. Mass of the solute or weight of solute, that we can denote with W2. M2 is nothing but the molecular weight, gram molar weight, okay, of the solute. So it means with the second number we can denote this one. So this one we can write here. So how it comes in the place of into what we can write W2 by M2 we can write W2 by M2 into 1000 by V, that means volume. Here no number I am writing, V only I am writing. V1 if I write, it is of the solvent. V2 if I write, it is of the solute. But no number I am writing means it is of the solution. Understood? So volume in milliliters. So this is the complete formula of the molarity. Understood this all of you? So it is the complete formula of it. Understood this one? So it is about the molarity. Okay. So on the basis of how the questions are asked, that I will tell you. But the remaining 2 or 3 synonyms also are very important synonyms about them. Now let us explain on this one. In the same way, the remaining also comes. Let us see. Next, molarity is over. Okay, about the molarity it is completed. Now let us see about the molarity. Difference is this. Molarity, just now before this one, molarity its units are moles per liter. Its units. Understood? In milliliters also we can change, but generally it will be in liters itself. Next, this one with the M also the units will be denoted. Understood? So it is about the molarity. Now let us say about the molarity. This one can be denoted with small m. Understood? Next, its units also what will be there? That moles per kilogram. Moles per kilogram. This one we can denote with the small m also. These are the units of it, and molarity can be denoted with the small m. Understood this one? Next, capital M means molarity. Small m means molarity. Okay. This one also definition if you write how it comes. Number of moles of solute present in 1 kilogram of solvent. Understood this one? 1 kilogram of solvent. This one definition is right. This definition is only for the concept it is utilized, but in the competitive level or in the calculation part it is not useful. What is useful then? Only the formula. Okay. So the formula is what we can write. Small m I am writing here. Small m means it is the small m means it is the molarity. Molarity equals to number of moles of solute by what we should take here 1 kg of present in 1 kg of solvent. That means mass of the solvent, weight of the solvent. Okay, so mass of the solvent or weight of the solvent we can write anything also. Weight of solvent. That also should be in kilograms itself. In the kilograms itself. So this one into grams, if you change, how can you write N2 equals to N2 into 1000 by weight in solvent. That means we can denote with W1. W1 first term can denote the solvent. Just now also I told you. In the instead of kilograms here, what comes here? Grams. What comes here? Grams. In grams, the units changed here. N2 means already you know, weight by molecular weight. So overall including the number of moles here, weight of solute by molecular weight of solute, okay, into molecular weight of solute into 1000 by mass of the solute in grams. So this is the complete formula of molarity. Okay, so it is about the molarity. Molarity, how we define that one molarity? గిటాక్స్ అదే 4 లైన్లు పెట్టినా రెడీ చేస్తే number of moles of solute present in 1 kilogram of solvent. Okay, so it is about the molarity. Okay, it is about the molarity and this is about the molarity. Molarity formulas mainly we should see here. W2 by M2 means weight of the solute by molecular weight of the solute into 1000 by weight of solvent it comes. And here also same it comes, weight of solute by molecular weight of solute into 1000 by volume in milliliters. Volume it is of the complete solution. Okay, so this one it is. Next let us see. Next mole fraction. Mole fraction, this one can be denoted with kite. It is almost like a small x. Okay, for example, in a solution, two components are there, A and B. A and B. Two components are there. Okay. So from these two components, mole fraction of A we want to find. Mole fraction of A means mole fraction of A. For this one, what we can find here, number of moles of A by number of moles of A plus number of moles of B. Understood this one? So, for example, number of the mole fraction of the B you want to find. Then how it comes? Number of moles of B by number of moles of A plus number of moles of B. Understood this one? So like this, number of moles of, so what we can find here finally, number of moles of, for here the mole fraction of a component. What component you want to find? The what we create here, mole fraction of a component equals to number of moles of that component by number of moles of all components. Okay. What component mole fraction we want to find? That we should take the ratio between that component number of moles and the sum of the number of moles of all components. That is nothing but the mole fraction of that component. What component mole fraction we want to find? That first we should learn here. We should know the mechanically we should have. Then only we can calculate the mole fraction of any component also. Okay. Okay, for this one, from this one, question how it comes. Let us see. Mole fraction, molarity we learned, and along with them the routes also let us see. Okay, after before seeing about the routes law, one question let us discuss here on the molarity. So in the competitive question, how the question is asked, listen. If the question how it is asked, when the volume is doubled, okay, water becomes half. This kind of question once it came in the competitive exam. Okay, listen. It is very easy and some sense if you have to write easily. The options also what are given there? Molarity. What is given there? Molarity. Second one, molality. Third one, mole fraction. And the fourth one is weight percentage. Okay, so from this one, what is correct answer? Let us see. Very simple it is. Molality means number of moles by weight of solvent. Weight means volume is not there. Weight we can find that in the grams or kilograms only. So that is mass, nothing but. So it is not the answer. Next, mole fraction is there. Mole fraction also number of moles of that component by number of moles of all components. Understood? So it is also in this one also volume is not there. So this is also not the answer. Next, weight percentage means weight of the component present in 100 kilograms or grams of the solvent. Okay, so like that it comes. So it is only about weight it comes. Volume it doesn't come. You know that volume can be measured. Volume and mass, they are different from each other. Mass means weight. This one can be measured in kilograms or grams. Understood? Volume can be measured in liters and or milliliters. Okay. So like this, these are different from each other. Understood? That's why here what is asked, when the volume is doubled, in the question about the volume is given here. That means only we should think about the volume itself. Okay? Let us see. Listen. First one, molarity is there. Molarity, that definition we know already, just we discussed about this one, and the formula also we know. Volume, that is molarity, is nothing but the number of moles of solute by volume of the solute. solution in liters. That completely we learned about this one. So volume comes here. Volume comes here in the molarity. That's good. So this is the answer that we can write. Okay. The proof also, for this one proof also you will need. Then let us do it. When the volume is doubled, what becomes half? That should be proved here. Molarity becomes half. That also we can prove it. Let us see. Molarity means molarity equals to, okay, that is number of moles of solute by volume of solution. Here I am taking, it is of the A solution. A solution. Okay, the solution when it contains the volume, a certain volume, when it contains, then only we are calculating the molarity of it. Ma equals to N2 by Va. Okay. Next for this one. Now what happened here? The volume is doubled. Volume is doubled means so the Va it is doubled here. Okay, doubled means it is multiplied with the 2. That's good. So what comes here? Va into 2, that is 2Va comes. This one I am taking as a Vb. Vb means this is the double volume of Va. That's good. Now this one volume is doubled means this volume of molarity also changes. Mb comes. Mb equals to N2 by Vb comes here. Understood? So it is after we have done double the volume of it. Next from this one. Mb equals to Mb means after doing double the volume. Understood? Mb equals to N2 by N2 by V means what we can take? 2Va we can take here. 2Va. Understood? It is a double here. Okay. Next. Mb equals to what we can take? N2 by Va. N2 by Va equals to Na we can take. Okay. So 1 by 2 Ma. This one we can write here. This one 1 by 2 N2 by Va equals to Ma. Understood? So half into Ma means this one directly we can write Mb equals to Ma by 2. By 2 we are writing means it became half of the volume. Understood? So that means Mb when it is doubled, the molarity became half of it. Understood? The molarity, half of the molarity of the Ma initial molarity, the half of the molarity is equals to Mb. Okay. So when the volume doubled, it becomes half of this one. Okay, Ma is there. Half of the Ma is the Mb. Understood? That means the molarity becomes half of it. Okay, that's why this is the answer here. Is it clear? So like that, when the volume is doubled, molarity becomes half. Initially how much is there? For that one we should write by 2. By 2 we are writing means it is becomes half of the initial volume. Understood this one? That's all. Next. Let us say about the Raoult's law. Mostly Raoult's law for the non-volatile solute. Non-volatile solute. So this one what we take, that will be more important here. Okay, about this one only let us discuss more. Raoult's law, listen to this one. First, non-volatile solute means what it is? Non-volatile solute means it contains the more boiling point, and less fair, that is vapor pressure, less vapor pressure. Okay, so this kind of more boiling point, less vapor pressure, more boiling point, less vapor pressure. So these kind of sentences comparing to petrol, water is non-volatile because the petrol at the low temperature only it boils. Its vapor pressure also it is more. What's the petrol comparing to water? So that is the volatile solute. So when the solution contains non-volatile solute, then what we should take here? The relative lowering of vapor pressure we take here. Relative lowering of vapor pressure. Relative lowering of vapor pressure means the ratio between the lowering of vapor pressure and the vapor pressure of pure solvent. Okay. The lowering of vapor pressure and vapor pressure of the pure solvent. So this ratio is known as the relative lowering of vapor pressure. Understood this one. Next, P naught means what is that? P naught means vapor pressure of pure solvent. Vapor pressure of pure solvent. PS, it is nothing but the vapor pressure of solution. Solution means after adding the solute. That's true. So it is the ratio here, the difference between the vapor pressure of pure solvent and the solution, that is known as the relative lowering of vapor pressure. Relative lowering of vapor pressure. This one will be equal to the mole fraction of the solute when the solution contains non-volatile solute. Okay, so this is the Raoult's law. Understood this one? What is Raoult's law? Raoult's law, what it says? Very simple. If the solution contains non-volatile solute, then the relative lowering of vapor pressure, will be equal to the mole fraction of that solute. Understood? So this one it is known as the Raoult's. Understood? Next in this one. In this one. So again I will write it. Listen. In this one, mole fraction relative lowering of vapor pressure, it is equal to the mole fraction of the non-volatile solute. So this is the Raoult's law. So this how can we explain here? P naught minus Ps by P naught equals to here P naught. So let us see. P naught equals to X2 means what is that? Mole fraction of the solute. Second number denotes the mole fraction of the solute. Second number is of solute. First number is of the solvent. Understood? X1 if you write, it is the mole fraction of solvent variant. X2 is the mole fraction of solute variant. Understood this one? Okay. So mole fraction of the solute means okay, it is nothing but the number of moles of solute by number of moles of the solvent plus number of moles of solute. Okay. But in the dilute solutions, what will happen here? In the dilute solutions, in the dilute solutions, in the dilute solutions. Okay. So what happens here? The N1 value comparing to N2, it is very large in quantity. N2 value is very less. N2 value is very less. Understood? That's why in one word if we say it is negligible compared to N1. That's why this one in the place of N1 plus N2, it is almost equals to N1. That's why here what we can write N2 by N1 we can write in the place of this one. Understood? It's N2 by N1, how it comes? Weight of solute by molecular weight of solute into M also it comes same, but it is at the denominator here, that's why it will be reversal. So molecular weight of solvent by weight of solvent. Understood? So this is the complete formula. It comes from the Raoult's. Understood this one? On this also the problems will be given. Okay. For example, I am writing this one. In a solution, the molarity next along with this Raoult's law, we should know about the delta PB and delta TF also. Delta TF also. Okay. Delta TB means elevation of boiling point. Elevation of boiling point. Next, delta TF is the depression in the freezing point. Nothing is there, just a difference between the boiling points. PB naught means the boiling point of the solvent, pure solvent. Next, here if you write TBS, I am writing. TBS is a boiling point of solution. It is more than the TB naught. So subtraction while we are doing, from large number to small number is subtracted. So TBS minus TB naught. Okay. So this is the difference between the boiling point of solution and the boiling point of pure solvent. This difference is known as the elevation of boiling point. Okay. Next, in this one, depression the freezing point, what we can write here? Again, TB naught. In this one, it is more than the TBS of opposite to each other. So from big to small, we should subtract here TB naught minus TBS. Okay. So this is the depression in the freezing point. Let's go. So about them also you should remember. Next, let us see one another question. The number of moles of solute present in 250 ml and 0.01 mole solution. So this kind of one question may be given in that one. Okay. So what is given here? So totally it is completed. The question it is explained here. Now this question also I will write because it doesn't belong to the words. Okay, let us see again the question I will write. What question comes here? The number of moles of solute present in 250 ml and 0.01 m. 0.01 m solution. So this one we should find here. So how much can we? Listen, in this one what values are given here? The 0.01 m means it is the molarity is given. Here the volume also. So number of moles we should find it. Very easy it is. In this one, the formula molarity formula can be applied here. Molarity is there with the capital M equals to number of moles of solute by volume of solution. Okay, in liters, find this. It is important. Normally, while you are writing the formula, it will be in the liters itself. Now, in milliliters, if you check how it comes, N2 into 1000 by V in milliliters. Understood? Now, what we need here, M equals to this one comes. Okay. What we need here, N2 we need. Number of moles only asked here. So, N2 equals to what we can write here? M into V by 1000. So this V again in milliliters I am not writing because 1000 liter means it is in milliliters itself. It will be in the milliliters. Understood? So N2 equals to M into V by 1000. Now let us see. M value how much given here? M value is 0.01 is given here. Next V value how much is given here? V of this volume it is 250 milliliters. 250 milliliters. 250 milliliters by 1000. Understood? 250 1 ja 250 4 ja 1000. So what comes here? 0.01 by 4. This one how can we write? 1 by 4 into 10 to the power of minus 2 we can write. By if you remove this one here already comes that it means 10 square. That if you write here it becomes minus charge. Next 1 by 4 value how much is there? 4 1 ja 4. Here 1 doesn't go, that's why point we should write 0 comes here 10 becomes 4 2 8 2 remains 2 0 24 for you. So this is the answer 0.25 into 10 to the power of minus 2. Sometimes how it is given? 2 is written here. 2.5 the point written here 2.5 into 10 to the power of minus 3 also can be given. Both of them also or similarly also we can write. Understood? So like this the problems can be solved. Understood? So like this. What is given here? Mainly properly we should be able to apply the formula. What is there? Understood? What formula is there? And what formula can be applicable here? Okay, that first if you are able to find, then easily you can find the answer. First carefully you should read the question. Understood? If you read the question, then easily what values are given and what is to be found. Then also you can estimate, you can understand, and then the appropriate formula if you apply, then you can obtain the answer. First of all, you should have the grip over the principles, the equations. Molarity equation how it comes, molarity equation how it comes, mole fraction, okay, ppm, and next volume percentage, the concentration equations also are there, volume percentage, mass percentage, mass by volume percentage. Understood? So these are formulas. Next Raoult's law. Okay. Next lowering of vapor pressure, and in the elevation of boiling point and depression of boiling freezing point also. Okay, that is delta TB is directly proportional to molality, and delta T it is F also. Delta TF is the depression of freezing point. It is also directly proportional to that is molality of the solution. Molality of the solution. That's why these all also these maximum the formulas mainly for the competitive level you must focus on the formulas. Formulas properly if you remember, easily if you are able to find what the formula can be applicable here for this given problem, then 90% problem will be solved. The 10% simplification easily we can do. Understood? That's all. The process is very easy, but first of all, the total equations must be in your mind properly. Fluency in that if you get, then easily any problem also you can do. Understood this one? It is over. The remaining let us see in the next.